So today in this lecture I am going to do the numericals of electric charges and fields given under hit the target. You see here on page number 91. Page 91, hit the target from your book. So see here, I will just explain and numericals I will try to solve. You see the question number 1, you can open your book and you can see from the book also. With the help of the label diagram, obtain an expression for the electric field intensity E in the broadside-on position. Broadside-on position means equatorial position. This I have already explained in the class. So you will draw the complete diagram. Complete diagram means label diagram. It's clear. Diagram should be labeled as I have done in the class. You will show the directions of electric field due to minus Q charge, due to plus Q charge, and then you will resolve them, find out the resultant. So broadside on position, you have to derive this formula. It's clear. In this question, it is not given that the dipole is of a small length. Therefore, you will not neglect the term of L. But if it is given that the dipole is of a small length and then you have to derive, you will do up to this point. After that, what will you write? Since the dipole is of a small length, therefore the term of L can be neglected. When the term of L will be neglected, what will happen to this? R square power 3 by 2. That is equals to R cube. And when it will become R cube, what will be E? It will become 1 upon 4 pi epsilon naught. This is P. In numerator, it is P upon R cube. So this you can do. This question has been asked in these 3 years. Now you can see here, this has been further asked in 23 also. You see the second question. Second question is also the same. You have to do the derivation so that the intensity, so that means you have to derive. You will derive here. It is clear. In the broadside on position, so that you can do. Then next question, question number 3. Obtain an expression for intensity of electric field at end-on position. End-on means axial position. It's clear. That is axial position of an electric dipole. So you remember this thing, that the derivation of E due to the electric dipole on axial position, on the equatorial position, these derivations are very, very important. It's clear. You will draw the diagram and it should be properly labeled. You will show the directions of EA and EB as I have told in the class, and then you will derive. You will write all the mathematical steps, label diagram and all the mathematical steps. This is the required for derivation. Now next question you can see here. Force between two charges separated by a certain distance F. If each of the two charges is halved and the distance is also halved, means charge ki value becomes half and distance also becomes half. What will happen to the new force? So as you know that force is, this Coulombian force is proportional to Q1 Q2 upon R square. When the charges are halved, what will be the new force? F dash will be proportional to Q1 by 2 into Q2 by 2 divided by R by 2 ka whole square. So it will be what? Q1 Q2 upon 4 divided by R square upon 4. you will get the same thing. Means same thing, it means there will be no change in the force. Force will remain same. So such type of questions are asked in the 1 marks. That if the charges is doubled and distance is halved, then what will happen? Or charges is halved and distance is doubled, then what will happen? So this way you can find out the answer. It will come in objective. It's clear. So that you can do the roughly also. But in order to understand the concept, I have done here. It's clear. Then next question, question number 5. Which one of the following is not property of electric line of force? They originate at the positive charge, this is the property. They terminate at the negative charge, that is also the property. They intersect each other, they cannot intersect. Lines of force do not intersect, because if they will intersect, then what will happen? At the point of intersection, there will be two directions of electric field. What are the directions of electric field? That you know, along the tangent. So one tangent will be this, another tangent will be this, and two directions of electric field at the same point is not possible. So this is the option C. This is not the property. This is the property. A tangent drawn to the line of force gives the direction of electric intensity. It is clear. See the next question. Question number 6. An electric dipole consists of two charges, plus 2 microcoulomb and minus 2 microcoulomb. Means what is Q? This is plus minus 2 microcoulomb. So here only value is required for our purpose in calculation. So 2 into 10 की power minus microcoulomb. So this is perhaps microcoulomb, millicoulomb. M means millicoulomb. It is clear. I am solving from the millicoulomb. It is clear. And millicoulomb is what? Millicoulomb is 10 की power minus 3. It is clear. Because microcoulomb is mu c. Millicoulomb is this. So 2 into 10 power minus 3 coulomb. By a distance of 4 centimeter. Distance between both the charges in the dipole is represented by which symbol? 2L. Means 2L is 4 centimeter. So it is 4 into 10 की power minus 2 meter. It is kept at an angle of 30 degree with the electric intensity. Means this is the direction of electric field, and dipole is kept at an angle of, this is plus Q and this is the minus Q. This is kept at an angle of 30 degree. So you have to find the torque. And what is the electric field here? So here electric field is given 1 into 10 की power 5. This is actually 1 into 10 की power 5 Newton per coulomb. You have to find the torque. So now you know what is the formula of torque. Torque equals to P into E sin theta. So first of all you find out the P. What is P? It is Q into 2L. What is the value of Q here? Q is 2 into 10 की power minus 3. And 2L is 4 into 10 की power minus 2. That is equal to 8 into 10 की power minus 5 coulomb meter. Now you substitute here. Tau equals to P is 8 into 10 की power minus 5. What is E here? E is this. E is 1 into 10 की power 5. And sin theta, that is sin 30 degree. And we know that sin 30 degree is 1 by 2. So 10 की power minus 5, 10 की power 5 cancel. That is 8 into 1 by 2. That is 4 Newton meter. This is the unit of torque. So which option is correct? Option D is correct. It is clear. So all of you do all the questions which are given under hit the target. That is, these are the questions which are very important, and the same questions are asked. Can a body be given? This is 2.2 into 10 की power minus 19. 2.2 into 10 की power minus 19 coulomb. Whether this value of charge can be given to any body or not. So you find out the number of electrons corresponding to this. If this comes out in the whole number, then it can be given. Otherwise, it cannot be given. So how will you find? So N equals to Q upon E. So Q is given 2.2 into 10 की power minus 19, and E is 1.6 into 10 की power minus 19. So it is 22 upon 16, that is equals to 11 upon 8. It comes out in fraction number. It is clear. So this value of charge cannot be given to any body, because number of electrons which are equivalent to this value of charge comes out in the fraction. It is clear. So charge cannot be given. Integral multiple means whole number multiple. Now second part, when a torque acting on an electric dipole in a uniform electric field E is maximum. So that you know under which condition torque will be maximum? When the dipole is kept perpendicular to electric field this way. Here what is the direction of dipole moment? This is vector P. What will be torque? Torque will be equals to P E sine 90 degree. Sine 90 degree equals to 1. So what is the maximum torque? It will be P into E. So when it is kept right and perpendicular to the direction of electric field. Now you see the next question. Question number 8. It is clear. Here it is Q upon 4 pi epsilon naught capital L. Similarly in the other, it is clear, 2 pi epsilon naught L. You can see in the book. Now a short electric dipole is placed at the center O inside the large cube A, B, C, D, E, F, G, H of length L. Means inside the cuboid electric dipole is kept. Means this is the cuboid, and inside this cuboid dipole is kept. You have to find the electric flux emanating through the cube. So what is the formula of electric flux? It is equal to the charge enclosed by the cube divided by epsilon naught. So how much charge is enclosed by the cube? Dipole is inside the cube. What is the total charge? Minus q plus q means total charge is 0. Q in it 0, 0 upon epsilon naught 0 means B part. No flux will emanate from through the cube. कोई भी फ्लक्स क्यूब से बाहर नहीं आएगा, बिकॉज एज मच इज इन कमिंग आउट फ्रॉम द क्यूब उतना ही क्या है माइनस क्यू के कारण अंदर जा रहा, जितना प्लस क्यू के कारण बाहर निकल रहा उतना ही माइनस क्यू के कारण अंदर फ्लक्स जा रहा. सो नो फ्लक्स विल इमिनेट थ्रू द क्यूब. नाउ यू सी द नेक्स्ट क्वेश्चन. Gauss theorem of electrostatics. You have to write the correct statement of Gauss theorem. What is the correct statement of Gauss theorem? Electric flux enclosed by a closed surface. It is closed surface. Electric flux enclosed by a closed surface is equal to 1 upon epsilon naught times the total charge enclosed by that closed surface. You have to write this statement in verbal form as well as in the mathematical form. It is clear. if you just write this, you will get only 1/2 marks. This. So this is the mathematical form. In the language form also you write electric flux enclosed by the closed surface, because these are the qualitative terms which do not reflect from the formula. These qualitative terms do not reflect from the formula. So you have to write the statement also. Electric flux enclosed by a closed surface is equal to total charge enclosed by that closed surface. Now see the next question. A closed surface in vacuum encloses these two charges. So what will be Q in? Q in will be 2Q. इन दोनों का टोटल इज 2Q. सो व्हाट इज द total electric flux emerging out? 2Q upon epsilon naught. 2Q upon epsilon naught. It is clear. So questions are very simple here. In hit the target means the questions which have been asked in the previous years are very simple. In board, very simple questions are asked. It is clear. Now choose the correct alternative A, B, C or D. This you have to choose the correct alternative. You can see here the intensity of electric field at a point which is at a perpendicular distance from R from an infinite line charge. What is the formula of electric intensity due to an infinite line charge? So if the linear charge density is lambda, point is at a distance R, what is the formula? We know it is 1 upon 4 pi epsilon naught 2 lambda upon R, and sometimes we also write it as lambda upon 2 pi epsilon naught R. You cancel here, we by 2 you will cancel, 2 1 ja 2 2 ja. But in numericals we use this because we know the value of 1 upon 4 pi epsilon naught. So which one is correct here? Perhaps this option C is correct. 1 upon 4 pi epsilon naught 2 lambda upon R. Then next question you can see. Electric flux emanating from a sphere of radius 2 meter is 5. This is a sphere. Its radius is 2 meter. How much electric flux comes out from here? 5. If the radius of the sphere is made 4 times, there will be no effect in the electric flux. इलेक्ट्रिक फ्लक्स की वैल्यू में क्लोज्ड सरफेस के साइज से कोई इफेक्ट नहीं पड़ता, बिकॉज व्हाट इज द फार्मूला ऑफ इलेक्ट्रिक फ्लक्स? इट इज द चार्ज इनक्लोज्ड डिवाइडेड बाय एप्सिलॉन नॉट. सो whether it is the sphere of 2 meter or whether it is the sphere of 4 meter, it do not make any change in the electric flux की value में. It is clear. Therefore, it will remain same because both the sphere, this as well as this, both are enclosing the same amount of charge. It is clear. Then next question. The surface charge density of a large conducting sheet, it is 17.7 into 10 की power minus 6 coulomb meter square. This is the surface charge density of a large conducting sheet is this. The electric field intensity at a point just outside. So we know that what is the electric intensity just outside? It is sigma upon epsilon naught. Sigma upon epsilon naught. So that you can find, that you can do. It is clear. But this is not given, so you take it as this is what is sigma upon, you evaluate this. See here, this is equals to sigma upon epsilon naught. What is epsilon naught value? 8.85 into 10 की power minus 12. It is clear. Now see here, this is the not, it is not given a thin sheet of charge. So here we will take 2 sigma upon 2 epsilon naught, sigma upon 2 epsilon naught, because this is the single plate. It is clear. And from here, what is the electric intensity at any distance, whether it is just outside or it is 10 centimeter far from the plate, whether it is just outside or 10 centimeter far from the plate, what will be formula will remain this. But if it is given that it is a thin sheet means of finite thickness, it is a sheet of finite thickness, then it will become sigma upon epsilon naught. So we will take sigma upon 2 epsilon naught. So sigma upon 2 epsilon naught, sigma is given 17.7. 17.7 divided by 2 into 8.85. So it will come out 1 into 10 ki power 6. Calculation you can do. Here formula I have told. Then question number 14. You can see here. A hollow sphere of radius r has a point charge q at its center. Means this is the sphere, its radius is r and charge q is kept at the center. Electric flux emanating from it is phi. So phi equals to q upon epsilon naught. If both the charge and radius of the sphere is doubled, what will be the effect on the electric flux? So already I have told there will be no effect on the electric flux because of the radius of the sphere doubled. When the charge will be doubled, what will be the electric flux? 2 phi upon epsilon naught. Means पहले का 2 गुना हो जाएगा, पहले का 2 times हो जाएगा. It is clear. So that is 2 q upon epsilon naught means twice of the earlier. So now you can see the next question. A remaining question I will do. Now only 4 questions are left, so that I will do in the next video.